In this video, I'm going to show you how to find slope. Now, what is a slope? Slope is a steepness of a line. So the number for the slope tells you if the line is really steep or close to flat. Now, for example, if I have a person trying to go up a hill from left to right, and it's always from left to right because we write from left to right too, right? So if a person is trying to going up a hill, if the higher the slope, the higher the steepness, it's gonna be more difficult to climb. And if it's closer to the surface, the flat, it's gonna be easy to go up, right? And then the slope so tells us how steep line is, if it's really big or really small. Now, so let's try to find slope. To find the slope, you have to follow a couple steps. Now, step one, you have to find two lattice points, or you might have heard perfect points. They're the same thing. Now, what they are is, when you see a graph, line graph or linear graph that's going straight, you are trying to look for the points where your graph crosses the intersections on a grid. So I'm going up, 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 and there we go. We are crossing an intersection. So that's one lattice point. We're going up, 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 and this is not a lattice point because it's in the middle, right? And this is not a lattice point either because that's in the middle. But over here, right on the intersection it lands, that's a lattice point. And so I see a bunch of lattice points or perfect points on this graph. So you're gonna find two of them. Now I see 5. Actually, this 0, 0 is also a lattice point because that's on a crossing, right? So I see a lot of them, right? Which one do you use? Now, the answer is it doesn't matter which one you use, as long as you use 2. It's the same hill, right? Same line, so it doesn't matter what you use, it will still give you the same number, same slope. So let's say I'm gonna use this point right here. I'm gonna draw an arrow, and I use this point right there. So these two. Okay. So step 2 is to draw a right triangle. Once you get used to it, you don't have to draw a right triangle, but for now, drawing one will help you. So I drew a right triangle. I know this is one because that's a right angle. Now, on a side note, I have some people trying to draw a right triangle on the top of the line, like that. Again, it doesn't matter which side you draw your right triangle, on the top or on the bottom. Okay, whatever you prefer, that's your choice. So I'm going to use the one on the bottom. Okay, so I drew step 2, right triangle. Step 3, I have to find vertical and horizontal distances, and I put these arrows to show you what vertical and horizontal means. Vertical is the one that goes up and down. Horizontal is the one that goes left and right. So on my right triangle, I have my horizontal distance, and again, left to right, okay? Point on the left to the point on the right. And I have to go up. There we go. So I have my horizontal and my vertical. So I have to know now the distances for these two parts, right? Let's look at my horizontal distance. I start from here, I end up right there. I have to count. Now before that, note where you begin. I begin at 2, right? And then I end at 6. So what is the distance? I can do 6 minus 2, which is 4. I also know that each square is going up by 1. 1, 2, 3, 4. It's going up by 1, right? So I can count 1, 2, 3, 4. 4. So 6 minus 2 is 4, or I can count 4. And it's going up, right, from 2 to 6, so it's a plus 4. I'm adding 4, because 2 plus 4 is a 6. So that's my horizontal distance. What about my vertical distance? I have to note then, again, I start from here. So vertical is top and bottom, so I look at number on the left. Over here on the y-axis, I start at 10, and I end at 30. So how do I find the distance? 30 minus 10, which is 20. I also know that each square is going up by 10. 10, 20, 30. So I can count here 10, 20. It's going up, so it's a positive. Notice how horizontally it went up by 1, on the vertical it went up by 10. So you have to be careful to look at the scales on your graph to see how much it's going up by. Note where it starts, note where it ends, and you can also subtract to find the distance. So I got my distances, my horizontal and vertical distances. So now I need to put in my slope formula, m, which is for movement, because you move from left to right. Movement is equal to vertical over horizontal, so I'm going to put that in. My slope movement is, what is my vertical? That's going up and down. That's plus 20, right? So I put plus 20 right there. What's my horizontal? That's left and right. That's plus 4. So I'm going to put plus 4 right there. And there we have it. Now, they're both pluses, so I don't have to worry about the sign. And so this is 20 over 4. Now, if you leave it here, okay, good. But if you want to go one step further, look at the numbers. We have 20 on top, 4 on the bottom. I know I can divide both top and bottom by 4. Because 20, I can divide by 4. 4, I can divide it by 4. So what do I get? 20 divided by 4 is 5. 4 divided by 4 is 1. And I also know that any number divided by 1 is the same, so that is 5. So what is the slope for this line? The slope is 5. Positive 5, right? So that is, there you have it. That's how you find slope. So whenever, so you have to remember the slope is vertical over horizontal. You're using 2 lattice points or 2 perfect points to find the distances. And there we have it.